Section 3.3 is proving lines parallel. So in the title, obviously you might have a few more proofs today. If there are some that aren't partially given to you, I would give those to you at the end. So we're going to determine whether two lines are parallel this time. First theorem, the converse of the corresponding angles theorem. So I want you to write the words, give the number, just those things that I have in purple, please. This one says if two lines in a transversal form corresponding angles that are congruent, then the lines are parallel. So if you look right above this theorem 3.4, notice that I added to prove lines are parallel. If you guys want to put that in your postulates and theorems section, go for it. There are going to be some that ask you what kinds of angles they are. And there are some that are going to say, I want to know, are these lines parallel? So if you're looking for the correct reason, that's what you're looking for is, do you already know the lines are parallel? If you do, use the theorems we've already done. If you don't know they're parallel, then you're going to look to these new ones that we're going to write today. And again, this one says if two lines in a transversal form corresponding angles that are congruent, then the lines are parallel. So we're showing that they're parallel rather than already knowing that they're parallel. So here's problem 1, identifying parallel lines. Which lines are parallel if angle 1 is congruent to angle 2? So here's angle 1. Here's angle 2. What kind of angles are those? What? Nope. They are on the same side, but not if it was 1 and then like this one right here. Those would be same side. What kind of angles are these? Corresponding. So we just had a new theorem that said if corresponding angles are the same, which they are, the lines are parallel. So the new thing is you have to identify which lines are parallel. So that's going to be the tricky part. So sometimes it's easier to kind of break out and draw a new picture. That's what I'm going to do because we have lots of angles in there and we have lots of lines. So the thing I'm looking at is the lines that are attached to those two angles only. So what I'm looking at are these. So 1 is here. 2 is there. I'm grabbing the two lines that go with each one of those, and I'm naming them again. There's M, A, and B. So there will be two lines that look parallel. Those are the ones that are parallel. The other one is the transversal. So the one that cuts through both of them is the transversal. This time that's M. And the two lines that are parallel would be line A parallel to line B. And you need the symbols above those with the parallel symbol, or you could put line A and line B because they're asking you if they're parallel, so either one is okay. The rest of the lines, line L doesn't even touch either one of the angles, so that one isn't included. Which lines are parallel if angle 6 is congruent to angle 7? So I'm going to do this one in a different color. I'll do green. So 6 and 7. What kind of angles are those? Corresponding again. Remember, same side, go here. 6 and the one that's missing right there are same side. These are both in the same spot. They're corresponding. So when you look at this one, the picture that I'm looking at kind of looks like this. So that's B, that's L, that's M, here's 6, here's 7. So the two lines that look parallel are parallel. So in this one, if 6 and 7 are the same, they're corresponding angles, we're going to use L parallel to M. And the theorem that we used on this one is the one that we just wrote down today, theorem 3.4, converse of the corresponding angles theorem. If you have corresponding angles theorem, that is incorrect. You have to have converse of it, or you have to use theorem 3.4, the one that we just wrote down. If you don't have the word converse in there, I will not give you credit because it's not the same. And this one would be the same. I'll do theorem on this one just so you can know you can use theorem numbers if you want to. And that's the one that we just wrote down today. If you use the corresponding angles theorem or postulate, that one might have been postulate, it's saying that the lines are parallel already, and then corresponding angles are the same. This is not the same thing. So we don't know that the lines are parallel. We're showing that they're parallel this time. So that's basically the difference. Then we get to a couple more. Here's what I want you to copy on both of them. Names of both, words on both. So I'll give you a minute to do those. Theorem 3.7, one more time. Converse of the alternate exterior angles theorem. If two lines in a transversal form alternate exterior angles that are congruent, then the two lines are parallel. So all of them have congruent pairs that we know already, except for same side interior. Those need to be supplementary in order for them to be parallel lines. And if you have a picture that is really super complex and there's so many angles in it that you don't even know where to start, pull those angles out that you have, and you're going to choose the angles that are on one side of the angle as well as the other. So just do the ones that are touching those particular angles, forget about everything else. And generally, the one that touches both of the angles at the same time is the transversal. The others only touch that particular one. So here, this one would be the transversal, where your lines that are parallel would be the ones that only touch that specific angle that it is at. Okay, so here's a little proof that you might want to jot down. Converse of the alternate interior angles theorem. They're pretty simple, usually about 4 steps or so, but at least if you write one down, you're going to have something to look at for any quizzes that you might have. So with this one, we are proving the converse of the alternate interior angles theorem. We're given that angle 4 is congruent to angle 6. They do have it marked in the picture. If it's not marked in the picture, you should mark it so that you know kind of what is given. And we want to show that a line L is parallel to line M. They have these in italics. If they don't, you should put the little line above it like that. These are in italics, so we can leave them just like they are. So I would definitely do the given, the prove, and the picture, and then I think it is 4 steps. Yep, it's 4 steps underneath. Yeah. So you can leave like 4 blanks when you get there. So at the end, we are trying to show that line L is parallel to line M. And at the beginning, they have angle 4 congruent to angle 6. So right now, even if that's all you knew how to do, you'd get 3 wrong versus 5 wrong. And we'll go from here. So does 4 and 6 have anything to do with 2 and 4? Are they anything the same? No. So what kind of angles are these two? Vertical. Don't we have a vertical angles are congruent theorem? You can either pull the number of that theorem out, but that's why they're congruent. And we're going to say vertical angle theorem. Anytime we use transitive, don't we use 2 things at the same time? We're using these 2 together to get this one. So when I put 4 and 6 together and 2 and 4 together, the 4s are the same. So don't the 2 and the 6 have to be the same? So this one would be angle 2 congruent to angle 6. They say transitive. I'm going to say substitution on this one. Again, because they're not exactly in the right order that transitive looks like. And when they switch stuff up, sometimes it's harder to tell what you're doing. So since the 4s are the same in steps 1 and 2, the 2 and the 6 have to be the same. And I'm just substituting one in for the other. And 2 and 6, what kind of angles are those? corresponding. Didn't we just have a theorem that said if we can show that those two angles are the same and that they're corresponding, the lines would be parallel by that converse. So we're going to say converse of corresponding angles. Is it theorem or postulate on that one? Theorem. Yep. You can put theorem 3-4. I just don't have them memorized in the numbers, so but you can use numbers if you want to. On tests and quizzes, I usually have both, but when I'm working on them up here, I just remember the names.
So for the third row down, did transitive and substitution property fall for?
Either one. Yep, I would count either one. Okay. Yep. The book will always use transitive property when you're using those two steps together, generally. But if it's something like you have something in the picture that you're plugging in, that's when the book will use substitution. I just feel like this looks more like substitution because they're not in the right order. So either one of those reasons would be fine. Okay, here we have another one, prove theorem 3.7. Angle 1 is congruent to angle 7. I'm going to put that in right away. Prove L parallel to M. I'll put that in right away. And then we'll fill in the steps. So I'll give you guys a minute to copy the given, the prove, the picture, and then you might want to fill in the partial proof as well. So step number 1, the reason would be given. Now on this one, if you look at the end result, we need to show that these are parallel. The only theorem that we have so far that's showing that things are parallel is the converse of the corresponding angles theorem. So when you look at this one, angles 3 and 7, aren't those corresponding angles? They look like they are. If we can show 3 and 7 are the same, which we're going to do in that third step, you could actually put this in there already. And that's only because some stuff is given to you. Okay, but you can put it in at the end as well. So I'm going to erase those back out. Now 1 and 7 were given and they are the same. When you look at this picture, we've got a couple of pairs of vertical angles. We need to figure out which one is the best to use. So should we use, which one is vertical to 1? Okay, so I'm going to go, we could use angle 1 is congruent to 3. I'm not going to put it in there yet because I want to pick the one that actually works with what we have. And then we could also do 5 and 7, right? Which one do you think is better to use? Is there one that's better than the other? Okay, and why do you choose 1 and 3? It's the right one. Yep, so when you're looking at it, if you have to end up with something that has a 3 and a 7 in it, shouldn't you probably pick the 1 and the 3 so that that 3 could possibly be there? So I'm going to write it in. And you know what? You might try something that doesn't work. Who cares? Try something else after that. So let's say we're just guessing and we want to choose 1 and 3 because we're not quite sure. If I look at this one and I say 1 is congruent to 7 and 1 is congruent to 3, wouldn't 3 be congruent to 7 by substitution or transitive? Same as what we did before? Yes. And I'm going to go back and I'm going to do, if I put a 5 and a 7 in there, what would it look like then? So this one's going to be transitive property of congruence or substitution. And we already said that that last one was the converse of the corresponding angle theorem. So if I go back and let's say at the beginning I wanted to use 5 and 7, would that have worked? Okay, so I'm going to take it out. You guys leave it the way it was. Okay, so I'm going to change colors just to show you that this is just something I'm showing you. If I put angle 5 congruent to angle 7 in there, what would this step right here have to be? If 1 and 7 are the same and 5 and 7 are the same, wouldn't that have to say 1 is congruent to 5? That's what I'm trying to show you. So even though 1 and 3 are vertical and 5 and 7 are vertical, they don't both work. Okay, so I'm going to go back and change it back to what it was. 1 and 3. Okay, this one is not a proof, but you kind of have to tackle it kind of like a proof. The fence gate is made up of pieces of wood arranged in various directions. Suppose 1 and 2 are the same. 1 is here, 2 is here. They put the numbers in yellow. You can't really see them that great. They're saying 1 and 2 are the same. What kind of angles are those? One is on one side of the transversal, the other is on the other side. Alternate exterior. So didn't we have a converse of the alternate exterior angle theorem? We did. That's what makes these the same, or the lines parallel. So we're going to say yes. Converse alternate exterior angle theorem. Or you could use the number as well. I don't know what number it was, but. So if you just say alternate exterior angle theorem, you will not get credit for this one. You have to say the converse because we were trying to show that the lines are parallel. Would you have to do 1 and 3 are the same, 2 and 3 are the same, and that? No, it's not asking you to prove it. It's just asking you which ones are parallel. Is there more than one way to prove that the lines are parallel? Yes, it just depends on your method. So if on that other proof they didn't have in there 1 and 3 were the same and you could pick your own, you could have chosen the other set of angles there. Okay, so if we go back up and look at this one, if they would not have chosen 3 and 7 in here and they would have put maybe 5 and 7 instead, or 1 and 5, you could have done something different. Or if you were doing that proof on your own, you certainly could have picked the other set as long as you pick the right set of angles at the end. Yes. Because you can pick from converse of the corresponding angles, converse of alternate exterior, converse of an alternate interior, converse of the same side. There's lots of different theorems that you can pick. Okay, so these are the ones that most of the time students do very well on. What kind of angles are the two that are shown? What? Nope. Same side interior. So are same side interior the same or supplementary? Supplementary. So we are going to set these equal to 180. And we're going to solve for x, and we're going to force them to be parallel. Okay, so if we solve and get a number so that when we solve we get what that x is, so we get 2x plus 120 equals 180. Subtracting 120, you get 2x equals 60, x equals 30. If x was 30, that would force those angles into being supplementary, and we know that there's a converse of the same side interior angle theorem that would make those lines parallel. So here you don't have to give reasons, even though you're looking at the kinds of angles and making them parallel. Oops, sorry. The next one, what is the value of W for which C is parallel to D? Again, they're forcing these into being parallel. What kind of angles are these? Corresponding, and I'm going to write same side on the other ones, just so we know what kind of angles we're talking about. So we have a theorem that says if the corresponding angles are the same, then the lines are parallel. So we're going to force them to be the same. 3W minus 2 is equal to 55. We would add 2 to both sides and divide by 3. I think that's right. W is 19. And that is it. So lots of different theorems. In order to get these right today, if you're doing the words, you have to have the word converse in them. If you're doing the theorems, they have to be theorems that are above theorem 3.4 today. Once we pass today, it gets a little harder because then you have to know, do you choose the regular theorems and show that the angles are the same, or do you choose the new theorems and show that the lines are parallel? So you really have to pay attention to the wording on these once we're done with this section.